Hello, geometry students. Today we're going to be covering the, I think it's unit 8 activity that talks about that all circles are similar to each other, basically. So let's go ahead and get to that. Let me share my screen with you. Okay. So you can go ahead and go to page 5 on this, and we'll start from there. And you're going to need this GeoGebra link, so go ahead and click on that. And it should pull up GeoGebra. Hopefully you're familiar, at least somewhat, with this. Now, it says, part A, start by creating 2 different circles. Create a point and label A to make the remainder of the activity. Choose integers for X and Y coordinates of A. Create a circle with its center at point A and a radius of your choice. To make the remainder of the activity easier, choose an integer value for the radius. Okay, and do the same thing. Okay, so we're going to create 2 circles here. And it's basically saying that we want a circle. And we're going to use 2 coordinate points that are like whole numbers. So I'm going to do 5, 2. Okay. And we want to make the radius of this circle also a whole number. So don't go between 2 of these odd lines, go like right at the end. So maybe like this. So now we've created this circle here, and it has center at 5, 2, and it has a radius of 1, 2, 3, 4. And let's create another circle in the same way. Here I'll do it at -3, 4. And maybe the radius of this one will be 3. Okay, so now we have 2 circles. And take a screenshot and put it in the space below. So we're going to go ahead and use the snipping tool. Got our screenshot, copy, paste. Well, let me paste. So what we can do is we can save the image. It is capture. And then when we go here, insert image, and go to choose file and capture. And it'll show up just like that. All right. I know this was supposed to be circle A and circle B, but we're going to be using circle A and circle C. Different circles, that's fine, but I'm using these circles here. Okay, here's another example you could use. Recall what you know about similarity. If circle B is similar to circle A, what must exist? So if 2 shapes are similar to each other, then there must exist a transformation that maps one shape to the other. Maybe I should add a little more here. In order for 2 shapes to be similar, there must exist blah, 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 blah. Okay, that looks good to me. Next. I'm going to zoom in a little bit. What is the difference of the x coordinates from point A to point B? And again, I'm using point A and point C. So what's the difference if I'm going from point C to point A? What's the difference in the x? So how much am I moving over? So it looks like on the x, this one C is at -3 and A is at 5. So it'd have to be +8. 1, 2, 3, 4, 5, 6, 7, 8. So the distance here from C to A is a distance of 8 horizontally. Again, I'm using point C, so, but if you have point B, that's fine. I'm going to say point B. A. Let me word it a little bit different. The distance from point B, the horizontal distance, we'll say, is 8 to the right. If you use two different circles, then that'll be different for you. In terms of rigid transformations, reflections, rotations, translations, what does this difference represent? So if you're moving from one circle and you're moving to the right, well, that if you're just moving it over, that's a translation. So this represents a translation of 8 to the right. Now, what's the difference between the y coordinates? So take a look at the y coordinates. How would I go from C to A? Well, the difference there is 2. It's down 2. You see that? So I answer this one similar to how we did this one, except now it's a vertical distance down 2. So answer that one, part E. In terms of rigid transformations, flexions, rotations, translations, what does this difference represent? So again, anytime you're shifting it, this represents a translation, once again, of down. What's the ratio of the radius of circle A to the radius of circle B? So again, the radius of circle A is 4, and the radius of my circle C, or circle B, whatever you want to call it, is 3. So what is the ratio of the radius of circle A to the radius of circle B? Our ratio would be 4 to 3. Or in other words, if you want, you can write it as a fraction. 4 to 3. Okay. But write it in a complete sentence, right? Like, oh, the ratio of the radius of circle A to the radius of circle B is 43. Next, in terms of non-rigid transformation, what does this ratio represent? Well, when one thing is made bigger than, or made bigger or smaller, but retains its same type of shape, we call that a dilation. So this represents a dilation. Of, we were going to, it depends. If we're going from the smaller circle onto the biggest, then it'll be 4. In other words, 4/3. Or a sequence of dilation and translation that maps circle B onto circle A. So it's basically what we've already discussed. So in our case, we, I guess I can put it as I can translate circle B 8 to the right and 2 down. Then dilate circle B. Spelled circle wrong every time. Circle B by a factor of 4/3. What would that look like? So that's like if I grab this and I move it 8 to the, oops. I don't want that. Move this. Okay, move the little circle. But basically we take the smaller circle and if we move it 8 to the right, 2 down, and then dilate by a factor of 4/3, you'll get this circle. And so that shows that those two circles are similar because we found a transformation that maps one circle onto the other. So we could say that the two circles are similar. And we could put as their this information that maps one circle onto the other. So you have established that circles A and B are similar. What conclusion can you make about any two given circles? So we just picked these two circles out of thin air. So really any two circles would be similar to each other. So we can conclude that any two circles will be similar to one another. In other words, all circles are similar to each other. For assurance that similarity proof can be generalized to all circles, try more examples of creating two circles and determining the similarity transformations that map one circle onto the other circle. Take a screenshot of the two circles labeled C and D that are different from the ones you created in part A. So here we're going to make two more circles, and again, you can make them however you want. Let's do one right here. This one is at 9, 4 for its center and a radius of 2. And the other one, let's put it, why not here? This one will have a radius of, we'll put it right here. And this one will do a radius of 5 maybe. And let's make it 6. Okay. So, but you can make any two circles you want, really. Take a screenshot with the snipping tool or whatever screenshot tool you have. Save it, put it onto here. And then write a sequence of dilations and translations that map D onto C. So in other words, how would we map this circle onto this circle? So in this case, we would say, well, we would translate 9 to the right and 1, 2, 3, 4, 5 up. And then we would dilate by a factor of 1/3 in this case. because we're going from a radius of 6 to a radius of 2. So I want you to explain that here, or whatever two circles you chose, or if they're different circles, make sure to explain how to translate and then dilate to go from one circle to the other circle. This is just basically showing what we've already done before. All right, and that's it. Well, that wasn't so bad. So I hope that made sense. If you still need help with this assignment, of course, you could always pause, rewind, watch it again, but you could also email me if you want help with any of this or anything else in geometry. My email is ttrigg@ofy.org. That's ttrigg@ofy.org. All right, I guess that's it. I'll see you guys next time.